that's much better. Okay. So we've already talked a little bit about sampling last class, but just to review, what did we talk about last time? What makes a good sample? So what makes a good sample?
Precise.
Michael, further wrong, sorry. So Michael.
It had to be precise and accurate.
It can have you precise and accurate? Sure, what are the advantages of sampling?
Cheaper, faster, more practical.
Great, you've been reading off the notes. So, what does that mean? Why is it cheaper?
It's just smaller. Really,
Exactly, right? But because we're only using a sample, a subset of the whole population, there are potential problems. As noted, right, a good sample has to be precise and accurate. So what is a precise sample? What does that mean?
Minimize error.
It minimizes the error. I want to build off that. So what the Sandra said. Want to add more?
Like fluctuation. A population due to random fluctuation.
What does that mean? Like, why is that an issue? Joyce? Joyce here? Or Rolanda. The question is, what does that mean that a precise sample reduces the, or like why reduces the random fluctuation? Like, why is that always a concern? Why is a sample size of 3 bad, but a sample size of 300 why? Okay. So what do you mean? What could happen if only a sample size of 3? What was your name again?
Anisha.
Anisha.
If you have 343, you get more response from like a variety of people rather than being restricted to a limited group.
So you're absolutely right. So a sample size of 3, for example, cannot, by the laws of mathematics, hold as much variety as a sample size of 300, right? Like you can't have like 22% feeling this way when you only have a sample size of 3, because only 1/3 could feel anyway. So you're absolutely right. There's another issue too. Name is? We'll be honest. Yes. Well, so that's going to be the accurate issue, and you're right, you can have an accurate issue. But there's another issue with a sample size of 3, that even if it's well gathered, you might have an issue, yeah. Okay, yeah. Tell me more, what do you mean, CJ?
So we sample, if one of them is way much different than the other 2, or the other 300, like average or median would be different.
Yeah, absolutely. So if we're trying to get the average height of Montgomery College students, there's going to be some people that are very, very short. There's going to be some people that are very, very tall. There'll be a lot of people that are in the middle. But if we only get a sample size of 3 and we select each person at random, right? Every element had an equal chance of being included in the sample, which is the definition of a good way to gather a sample, a simple random sample. There is a chance that by luck we picked the 3 tall people. And we would say, oh, I guess everyone at Montgomery College is really tall. Like, well, no, the sample's too small. It's not precise enough. It didn't minimize the natural sampling error that occurs when you select things at random. So that's why we want larger samples. Because if we go from a sample size of 3 to 300, the likelihood that all 300 are unusually tall, or the likelihood that we got even an unusual amount of unusually tall people, becomes smaller and smaller as our sample size increases. So you always want your samples as big as possible. The problem is, someone asked last section, like, well, how big is too big? The answer is it's never too big. Sometimes you will run into issues of cost, because it takes time. Larger samples take more money to gather than smaller ones, so you have to hire more people to gather them. It takes time, right? So you will run into those logistical constraints, but as far as the math goes in stats, bigger is always better. The business part of it is, sometimes big is just too impractical. This happens a lot too in psychology research. So a lot of psychology research, while involved, it's usually undergraduates. There's a lot of psychology professors performing this, and they're at universities, and they get undergraduates to do like various experiments. And you can only get a few people to do it because these experiments are often pretty time-consuming to run. And so they might only be based off a sample size of like 10 or 15. And then unsurprisingly, when someone tries to replicate it, a lot of the times they can't replicate their results because the sample size is too small. Okay, so that's the accurate part. We didn't get, that's the bias part, the precise part. We didn't get to the accurate part, when a sample could be biased. We want to pass this around actually to make sure, yeah. Because I don't know, there's a lot of people that came in today, so let's pass it around. So, what would be an example of a sample? Because you've heard, right? I assume you've heard the phrase a bias sample before. So what would be an example of a bias sample?
I guess for you were to take a survey of what the majors are for you chose your classes. That class would be mostly business.
Most business, so obviously most people are business majors, right? Right? Exactly. That's a bad sample. Why is it a bad sample?
Because you only give classes that business students take, so there's a higher chance for the student in that class to have a business major.
Not only is it a higher chance too, it's also like there's a large group of people who can't possibly be included, right? Like there's a large group of people that can't possibly be included. This is an example of what we call undercoverage bias. So there's types of sample bias. And this particular version is undercoverage. I'm going to go in slightly different order than the notes because you brought up an example that was undercoverage. Undercoverage bias simply means that you, by the design of the experiment, certain observations or elements of the population cannot be included in the sample. Right? It's not simple random samples. Not everyone has an equal chance to be in, and some have a probability of 0 of being in. Not be included by design. Not be included by design. So, undercoverage is a very common type of sample bias. It's also a very subtle type of sample bias. It's not always. In this example, that's very clearly biased. That's very clearly problematic. We have good reason to think that the people who would be excluded from my class because they don't take it, right? It's not required for them. And they can't include everyone, obviously. Would be different than the people who are in. So we should add to that this is something that matters. Exclude observations in a non-random way. great example of this from a book by Elizabeth Pisani. What am I saying? Pisani. So, Elizabeth Pisani is an epidemiologist. Does anyone know what an epidemiologist is? Anyone want to take a guess? Epidemics. The epidemics, the spread of infectious diseases. And she has a specialty in AIDS, spread of AIDS, and HIV. So she works for the World Health Organization, she's worked for the CDC, and similar organizations, and a lot of her job involves going to various countries and figuring out how the disease is most commonly spread. Because if it's spread largely through needle sharing, then that suggests that the organization should focus on making sure people had clean needles. And that would be the most effective use of resources to prevent the disease from being spread. Well, if it's tentatively spread through unprotected sex, then that suggests that they should focus on providing condoms for people. So she has to figure out which way is most common and figure out how bad each method is. Well, what's a very common way of unprotected sex? Is it through people who know each other? What's the most, when is unprotected sex most of concern? Sexual intercourse between, thinking about the relationship, between strangers. Between strangers. Between two people, this becomes biology classes. No. So typically it's between, in other words, particularly it's of concern when it's between, say, a prostitute and her client. So her job involved, weirdly enough, she has a PhD in epidemiology, and she goes to, in this case, Indonesia, in the quote I'm going to read you to, and she talks to prostitutes, what they call waria there. Okay. The book. So she explains in her book. Now, in order to get an idea of how she's going to do this research, right, she has to actually talk to people in the process of setting up shop. And so in her conversations with Roria, she gets the impression that they are performing dozens of tricks a week, having dozens of clients every week. This is their job, right? This is how they get money. But she also knows that the random conversations she has with individual waria, the few people that she's talked to, not only is it imprecise, right? Maybe there's some randomness to that that's unusual in some way, but it's also kind of biased too. Like she's only talking to certain people who happen to be wanting to talk to her. So she performs a more systematic experiment of hundreds of waria, and people, and she has various research assistants, I guess, who do this, go out into the streets of Jakarta and talk to people who are trying to find clients, and ask them, how many tricks do you perform a week? And so forth and so on. And in this research, she found that the average was only 3, not dozens, 3 clients a week. And she's talking to a waria she knows, Ines. And this is how Ines responds. I had the impression from the qualitative research, as well as from Nancy, Lenny, and other waria who were doing dozens of tricks a week, but the study average showed only averaged 3. And since that figure came from 250 waria, selected at random, as the manual requires, because she was following the system, it was clearly more accurate than the qualitative research or my vague impression based on chats with 4 or 5 friends. 3 a week? You're insane, snorted Ines. But then look at who you asked. Ines left school at 14, but she's not stupid. So I explained to her how, through our probability sampling, we were asking a representative sample of Jakarta's waria. Enos dismissed my lecture with a wave of her manicure and a flick of her locks. So clever, but so stupid, she sighed. What is she seeing that Dr. Dasani is not? What do you think she's seeing that Dr. Dasani is not?
I want to start telling people that want to give her information.
What do you mean? What kind of people?
Like in this case, people that like, it's like you're talking about prostitutes, so maybe if like the prostitute would be ashamed of having a lot of clients, maybe then like only the prostitutes that would have like a little, like a lower number of clients.
Okay, maybe they don't want to admit, right, for whatever reason. So that could throw things off. Absolutely. Though, you know, when she was talking to some people, they seemed to almost brag about how many clients they had when she was having these casual conversations. Any other ideas? You have something? No? Yes. So the question is, her study suggested only 3 clients a week, but casual conversations suggest it should be dozens. And the expert in this, warrior she's talking to, the friend of hers, says, no, your study is flawed. How do you think the study is flawed that results in such a lower result? It obviously should be much higher. What is the doctor missing? So you're saying maybe they don't feel comfortable talking to researchers? Yeah, maybe. That's closer. That's close to what she's thinking of. But, you know, the people who are doing this, like, they have a whole manual in order to try to, and training to make sure that they can approach them in a respectful way and try to get them to open up. I mean, that might be an issue, but that's not what the warrior was thinking.
Maybe that would really reach clients, so we don't have to have as many clients.
Oh, but, you know, they're on the street, right, trying to find people. So, huh? Oh, they're all doing it at night. So that's when they're out on the street. But you're right, the type of day ends up being very pivotal here, but not quite the way you think. What was it again? I'm sorry, what was that again? Okay. Yes.
Well, they could only be going to one street, and then there could also be prostitutes that are not on the street that could never be in the
No, because that was one part of the reason why she got there ahead of time to do some research, is she knows where all the prostitutes tend to go. Right, now that's part of the manuals. Obviously you're right, that could be an issue, but that's something they foresaw in the manual. Let me read to you what she says. How she responds. So clever but so stupid, she sighed. She explained, as if to an enthusiastic but slightly dim child, that a warrior who is hanging around a street corner to be interviewed by her research team is a warrior who is not with a client. You're talking to all the dogs, obviously. What do you... Not something I learned in the lecture halls of London, not something that went to the surveillance cookbooks, but of course Enos was right, our sample biased toward the dogs. What do you mean? What are you supposed to mean by that? Looks? What do you mean? Sorry.
Yeah, more attractive, I guess, when they're not working, actually.
Yeah, you're talking to the ugly ones. Because the ugly ones don't get clients. So of course they're willing to talk to you. The cuter ones are busy. They're not going to talk to you. Right? They're working. Right? Oh, she's like, oh, damn it. You're right. We totally screwed this up. Right? You can't talk to them right there because they have something else to do with their time. You have to talk to them when they're not working. And so they had to redo the whole study, and they set up this, essentially this breakfast thing, and then all the people got word out that, oh, come here, you get a free meal, and that's when they interviewed them, like in the early afternoon, not like at 11 at night when they're working. Right? And that removed that potential for that undercoverage bias. Right? By the design of the experiment, you are excluding people who won't be included. Right? Because they are literally not there, they're somewhere else with a client. Right? Hence the name of the book, The Wisdom of Horse. It's a really fun, interesting book about the logistical difficulties of gathering data in the world, and also a lot of the bureaucracy around it, the business, and so forth. It's a fascinating book. So that's one of the subtle ways. You see all these subtle ways that uncovered bias can sneak its way into bias in general. Any questions on this? There's one that's similar to that, and that's a self-selection bias. So, here's an Amazon review of a new book by Ken Follett called A Column of Fire. It was released back in September, so not even 6 months old. You can see it has 2,616 reviews. And its average star rating looks like it's 4.5 stars. Its Amazon charts 15 most read. So, is this a book you would like? It's a novel, by the way, in case you're curious. It's a novel set in 1500s, mid to late 1500s England, covering the Reformation. I think it's like 800 pages long, or 700. I can't remember. Would you like to read this book? Raise your hand if you want to read this book. Okay. I'm most of the way through it. I'm almost done with it. It's pretty good. Why do you want to read it?
It seems to have a lot of positive, like almost 5 stars. 2,600 reviews.
Yeah.
The design seems pretty cool.
Yeah.
And it says number 1 New York best time, so.
Yeah, right. Lots of other people like it. Right. So the question is not necessarily why do you like it. The question is what's wrong with all you people? Why don't you want to read it? Why did you not raise your hand? Love it. But it's got 4.5 stars. Right. Is that most of your impressions? Is that a similar conclusion? So, why then do you think it has 4.5 stars if most people here wouldn't want to read it?
Because people who read that genre must really like the book. It's only like focus on those who really like that kind of stuff. But don't to me that kind of fiction.
Exactly. You can think of this 2,616 reviews as a sample. It's a big sample, but it's a biased sample. It does not reflect the whole population of the reading people who might be interested in reading a book, right? This is historic fiction. This is not something that a lot of people might want to read. Right? Only the people who have decided to buy the book, read the book, and reviewed the book get included in the sample. In other words, these individuals choose to be in the sample. Right? And because the people who choose to be in the sample are systematically different than the population as a whole, the sample is biased. In observations, art. Sample resulting in a sample that underestimates or overestimates the population parameter. So in a non-random element that influences the sample. These sort of things happen all the time. So this is a poll result. The light's on, actually. This is a poll result taken from the O'Reilly factor back when it was on. This was some years ago. I think this happened during the oil spill that was in the Gulf of Mexico some years back in Deepwater Horizon. I think that's when this is happening. I got this a while ago. And what they do with these polls is at the beginning of the show, I never watched Bill O'Reilly, but I've watched enough of these kind of things. He would say something like, "There's a poll online. We want to know what you think, viewers. Go on and fill out the survey, let us know what you think." And then later in the end of the show, you show the results of the poll. What's wrong with this sample? Why does it say, what's wrong with this poll? Why does it say it's not a scientific poll here at the bottom?
Only people watching the show are gonna know that.
So only other people who watch the show are going to know about it, which is kind of like undercoverage, right? Because you are systematically excluding certain people. Right? They don't know about it. How can you possibly poll on it? But it's also an example of self-selection. How?
I was going to say, because you have to choose to actually go online and take the poll.
Yeah. This isn't even, what I love about this, it's certainly not a poll, a sample of all Americans or all voters. It's not even a sample of all Fox News viewers. Hell, it's not even a sample of all O'Reilly Factor viewers. Because as you note, there's an additional subset in there that says, oh, and these are the people that bothered to go online. Right? So there is that self-selection. What was your name again?
Like,
Any questions on that? Okay. I got a third one. And the third one is survivorship. Let's imagine you wanted to do a poll and you wanted to figure out if people who are in therapy liked their therapist. Because you're trying to figure out if therapists are in general good. Is the therapist in general good? What's the state of the therapy profession? So one way you do this is you will poll people who are in therapy. Do you like the therapist? The problem is you're going to get some people who don't really know anything about the therapist because maybe they just started. So, and you want it to be based on ideas that, some certain minimum amount of knowledge. You want them to know the therapist at least reasonably well. So you say, you know what, we're only going to look at people who have been with the therapist for 1 year. And amazingly, you find most people like their therapists. What's the problem with your sample?
They didn't like that therapist because you changed them.
Yeah. What do you mean? Tell me more.
So they wouldn't have been with that therapist for a year. So you have a good sample.
Mm-hmm. It's almost as if you created a test. And you said, only the people who have survived the therapist for a year get to be included in the sample. And that's the survivorship bias. It's not really telling us as much what we want to know about the sample. You're concentrating only on the observations that have endured or survived some process. And that survival is non-random. Biasing your sample. So sometimes economists want to know if the minimum wage has an effect on unemployment. Because if we increase the minimum wage, that makes it more expensive for people to be hired. So that Econ 101, or in this place 202, teaches us that, probably covered in 105. If you increase the minimum wage, you should have fewer people employed. Right? Well, to test this, see what sort of impact we have, an economist might look at some region right before the minimum wage increases, and they count to see, they interview, they like select some companies at random, maybe they locate only in the fast food industry, and they say, how many people do you employ? And they make it an average of employees. And then, after the minimum wage increases, they select a same number at random, a group of companies, and ask again, how many employees? And they get an average. And then we look at the average of employees before the minimum wage, and we see the average employees after the minimum wage, and in some studies, there's not really a big difference. But in some studies, and not every study who sees no difference has this problem because they correct for it. But some studies, when they don't see a difference, they've made a crucial error. In the way that I designed it, what was the error?
They could have picked no employees, or they could have picked no companies that had, what's it called, minimum wage employees.
No, because they're focusing on fast food, so they're all minimum wage, or a lot of them are. So maybe the red is before and the green is after. That's helpful. Yeah.
We didn't include the unemployment one, but you still working on that,
Well, but you're still checking to see the average number of employees, so we're seeing if the average number of employees fell. So we don't necessarily need to know the unemployment rate. We are looking at seeing the high, because looking at the unemployment rate as a whole is there's a lot of things going on. But if you just look at fast food, that sort of narrows the scope and helps clean things out. Like,
I was gonna say, it's probably the same because since the wages increased, people stayed at the job, or they didn't need to, they kept the job because their wages increased.
sure, but the concern from an increase in the minimum wage is not that people won't stay at the job, it's that the employers won't want to hire them anymore. They might be fired.
Everybody that they could have been there for a long time, so like if they were there for 2 or 3 years and then the minimum wage went up, like their boss might be less likely to let them get out.
That's true, but some people though surely will. So you're saying, oh well, some of them might have been there for a while. That's true, but also some of them might have been recent. So why don't we see an effect? I can't remember your name. Charlie. That's true. So one of the things that's really hard to detect in these studies is we don't necessarily know how many hours they're working. And if we know how many hours we're working, we don't know if maybe their work has become more inflexible. There's lots of ways. You're right. There's lots of metrics. This is what makes studying the minimum wage, even though it's so thoroughly studied, it's also very hard to study because there's a lot of things that can change. But I'm thinking more of a survivorship issue. So imagine you're a business, you see the minimum wage increase. Now, 2 things can happen. You can stay in business or go out of business.
So only the companies that were still in business.
Yep. The green ones survived the minimum wage increase, and those are the ones you're looking at. We're not looking at ones that don't exist anymore because they didn't survive the process that you're testing, the minimum wage increase. So again, it's a survivorship bias issue. Ideally, you would select companies ahead of time, before the minimum wage, and then look at those same companies again after. But sometimes that's logistically difficult to do, because maybe they talk to you once and then they don't want to talk to you again, something like that. But ideally, that's what you would do. And then you would get all the detail too on what happened to the individual workers and maybe interviews about the quality of the work and all these other things that could possibly change as a result of an increase in the minimum wage. Any questions about these three? So, oh yeah.
Just an example for me so I can understand it. So, for example, if you would say, okay, next week there's like ice cream party, right?
Okay.
The whole entire class. And then today, all of us, there was maybe like 10 people, the others were absent. And then those 10 people wrote down what they wanted. Would that be a part of undercover bias? Because next week, the other people didn't get to choose which kinds of ice cream they wanted.
So we're gonna say. Oh, you're saying when does only half people show up? So
on the day that you ask which kind of ice cream you want, two flavors.
Yeah.
Like we pick let's say strawberry, only because our kids today. But next week, the one that went here, they didn't want strawberry. Would that be bias?
It could be. The question is, why are the 10 people who aren't here? Why are they not here? Are they not here because they were giving out free chocolate ice cream somewhere else on campus? Right? If that's the reason why, then you're right. It's an undercoverage bias. But you bring up this really great point. This one I want to emphasize. Just because you can point to a potential problem with this doesn't mean it's actually an issue. Note in all these ways, in all these places, I mentioned there is some non-random thing going on. Like those 10 people are missing because there's another kind of ice cream that they like. They can get out. Well, now, if it was just 10 random people missing, then what's the difference between 10 versus 20? Maybe there's some precision issues, but as far as bias issues, it's not necessarily an issue. But if they are being excluded for a non-random reason, then it is an issue. So another example of this is Yelp. You go onto Yelp and you can see the various restaurants and how people rate restaurants. It does a pretty good job rating restaurants, right? The ones that are rated high are good restaurants. The ones that are rated poorly are not that good. The ones that are okay are okay. But Yelp potentially has self-selection bias. You choose to rate something. But because enough people choose to rate it, both for good and for bad, for okay, the rating correlates with the quality, and so the bias really isn't an issue.
Well, I was reading one where it was like that the users were biased because like that establishment was actually getting like a certain discount and people would use it all out. So I was like, where would that fall?
Well, it's tricky, right? Like, because you could give me a discount and I could say that you're terrible, right? But maybe the discount puts me in a good mood when I rate you. So that's a potential problem that any company would have to encounter. And that's tricky from a reviewer standpoint, from a consumer standpoint. Are these reviews biased because of that? And I don't know. It might be. Right? It might not be. Yeah.
And also the owner of the restaurant is themselves.
That's true. They could just rate themselves. That's obviously going to be an issue, right? That's obviously a bias issue. An old version of self-selection bias. But again, are these going to be enough to tilt the scales, right? Are they going to rate themselves enough that the self-selection bias becomes an issue? Are they going to be happy enough that they got a discount that's going to shift things away?
Would you consider Weight Watchers as a bias?
Well, I was going to bring that up. That's a great question. And I can't really answer that question. But you can answer that question. Do you, in general, find it useful that when a professor is rated high, you do indeed like that professor? When the professor is rated low, you typically do not like the professor? When they're okay, they're okay? Like, does it correlate in general?
Most of the time.
Most of the time, yeah. Case in point, do you use it?
Yeah.
After you've taken the classes, do you keep using it? Yeah. that suggests to me that it's pretty good then. That you're right, it has also potentially this issue of self-selection, but the question is that self-selection end up have a non-random result, have a biased result? Again, over or underestimating the population parameter.
Can you give a better example of the survivorship like in Farmers Day Life? Because you touched on the industry.
Well, I had the example of the rating therapists. I'm trying to think of good everyday life. Sometimes, and I don't want to draw too clean lines between them because sometimes there is a gray area. Like, I once took a survey from the power company, and like, you know how sometimes you're like, do you want to take the survey? And you're like, it'll only take 5 minutes. I go, okay. And it doesn't take 5 minutes. It takes like 20 minutes. And that could potentially be, I mean, it's self-selection in the sense that you opt in, but it's also kind of survivorship, right? Because you endured the 20-minute long survey, right? That the people who maybe are busy and too busy to do that survey, just like the warrior might be, you might decide that is actually going to bias the sample. Right? People don't survive it. And so there is a lot of gray area between these. One important distinction, though, between it, because the survivorship and the undercoverage have a lot of overlap. And one way to think about it is in an undercoverage bias, the observations by design cannot be included. They cannot be. While survivorship observations could be included. Right. Their exclusion is not their choice. Like maybe I'm filling out this really long survey and then my kids start screaming and I have to take care of them. All right, I have not survived your long survey. They didn't survive whatever criteria was set up. You can't tell from the beginning which will be excluded. Who can't tell from the beginning? So there are cases where it's a little vague. But these three categories sort of help you think about all the different ways that things can be biased, and that helps organize your thought a little bit on this, and helps categorize and consider the dangers. I can't remember your name now. Joyce. Any other questions? Okay.
I have a question.
Oh yeah, sorry. Yeah.
Sure. That could be undercover bias too, right? Undercoverage bias too, right? Because you would have certain restaurants actually have to want to eat that kind of food.
Yeah, but then it's like, it depends on, too, like, what you care about as a population. Like, if I like Indian food, do I care that someone who hates Indian food hates the Indian restaurant? Like, no. Just as similarly, I know that I like historical fiction. I don't really, so that sample that I showed earlier of the Column of Fire reviews makes sense that I would care about it. Like for Jeff Sawyer, and this is what's important too. What do you mean by population, right? So it's something that's not always appreciated. What do we mean by population? What are we actually getting a sample of? Any other questions? Okay. I'm gonna erase this. I'm gonna move forward. All this is in the notes anyway, so. I assume I can erase this now. Are we good? Yeah, great. Okay. So, let us switch gears and let's go on to data and displays. Something which we're not supposed to do until Thursday, but we'll work ahead a little bit. Data and displays always takes a while anyway. I should really break it into two. I want to start off by something you probably think is obvious, and you'll probably laugh at me for bringing it up. But you will be amazed how often I have this issue. Suppose I have the number let's make it 5,201,000. If I wanted to express this number in millions, how would I write it? In millions equals 5.201. How did you get that?
It says like 5 million. Oh, you just moved the decimal place 6.7.
Exactly. This is the decimal point. 1, 2, 3, 4, 5, 6. It's now there. And that gives us that. I mention this because when you work with data and you try to display it on a graph or in a table, you're trying to save space. You're trying to make it as easy to read as possible. And so often data will be expressed in terms of millions, or thousands, or billions. And I will also, in homework, thinking I'm going to save you time, tell you this is expressed in thousands, or express your answer in terms of millions. And you'll be amazed how many questions I get about this. So I just want to be clear how we do this. If this is, if I say, well, let's do this. Let's do 62,583 in millions. What is that? I like to put a 0 on the beginning, but yeah, 0.062583. That 0 in the beginning before the decimal point is obviously not necessary, but it looks nicer. Right? Because sometimes the dot is sometimes hard to see, so you put a 0 in front of it to just emphasize. What is this? In thousands. If I write 5.5K, what does that mean? If I write 5.5M, and sometimes it's decapitalized, sometimes it's lowercase, what is that? 5.5B. Billions, excellent. Oh, he's looking ahead. Right on the zeros, you realize why people just write T's and M's and B's. Really annoying. Out of curiosity, does anyone know why we use K for 1,000? Kilo. Kilo, Latin for 1,000. There's a Greek for Latin. It's Latin. Latin, good. We good on that? I'm not kidding. You'll be amazed. How many questions I've gotten over the semesters? When you said write it in thousands, what did you mean, David? I mean write it in thousands. People will say, I will say, like the answer might be like, I don't know, 6,000, and it will say write the answer in thousands, and people will write 6,000. That is not 6,000. It's in thousands. What is that? 6 million. What is the answer then? 6. Let's write 6. Please. Okay. Hopefully we won't have any trouble with that. All right, we're good.
No promises. No promises.
No promises. You know, I'm going to be when I'm talking to my wife. She'll tell me to do something. It's like, I'll do that, unless I forget. She doesn't find that very funny. I feel like I have to come back on that. So, yeah. Unless I don't do it. I'll do that unless I do it. Okay. In the time we have, I want to cover 2 different ways to display data that are very similar, but are very useful in different ways. We're not going to, I'll show you next class how to use them in Excel, how to make them in Excel. But for now, we're just going to cover basically what they are. I always lose my eraser. It's always right here. Let's imagine you had data on FICO scores. Does anyone know what a FICO score is? So, the credit score, excellent. What is the range of a credit score? Is it 350? Yeah, okay, 350 to 850. That's a huge range, right? That's hundreds of points. So how would you, if you had data on population, maybe like 100 or 1,000 observations, and each one of those observations was an individual credit score, 815, 630, 220, 320, well, I have to do at least 350, so 346, 364, I mean. You have a bunch of this data. How would you display it? How would you get a sense as to what that pattern of data looked like? Well, you get an average number, but then you don't know, like, so you might get this average number. It might be, I don't know, 629. You don't know if a lot of people have 629, or maybe very few people have 629, and the numbers are over here. And a lot of people have great scores, and a lot of people have terrible scores, and it's just, you don't. So how would you make a bar graph? What do you mean? So, oh, I know what you mean. You mean you're going to have, here is 350, and this is the number of people with 350, and here's 351, and the number of people with 350
with like sections, like how they do it on like one of the banking apps. They have like 350, like 450.
Oh,
national average and all this.
You're talking about a histogram. You said bar graphs.
I thought so. Like on that, they have like 300 to 400, or 350 to 450. And you know, 40%. You know, 451 to 550.
Kind of like this.
Exactly.
Yes. So this is what's called a histogram, where we take the continuous data and then we create bins, like up to 499, 500 to 549. 550 to 599, etc., etc. Note, each of these bins are of equal size. They cover the same range. Create bins of ranges. Each range is equal size. Or equal range, I should say. That's why are you sure it's 350? I thought the lowest was a 450. Yes. It's 350? Okay. Maybe. Yeah, and it's possible, so there's only 2% that's this low, so there's a little bit of give. Like they say, up to 499, so there might be so few people in the other ones that they just consolidated them. So we can say, just to cover up like a roughly equal size. Typically, they should be the equal size, especially the ones in the middle. The greater thans and the smaller ones is a little bit good there. Depends on what your data looks like for clarity. And on the y-axis here, it's either percent of something, like this is percent of population, or it'll be frequency, maybe the number of people. Obviously, percent of population makes more sense here because we're talking about a whole group of people, many, many millions of individuals. Now, the issue with the histogram, or an issue with it, is the look can change if you change the bins. Because bin size is somewhat arbitrary. When I look at this histogram, I get a pretty good idea, not just of maybe what the average is, maybe it's right about here, but also what the distribution is like. A lot of people have really great credit scores, and then it tapers off. At the same time, why 50? Why not units of 25? Or spaces of 100? Why 50? And the answer is 25 would have too many, and 100 would have too few. In other words, there really is no good answer. There's a little bit of arbitrariness, a little bit of give. And if you change what the bins are, you can get a radically different result. Like, if you look here, those things get better, and then it drops off. But if we had maybe 150 points, 150, 150, 150, in these individual 50 ones, it would always get better. And you wouldn't know that the people at the very top, there's not many people at the very top. Because you don't know what goes on inside a bin. I say somewhat, by the way, because and we'll talk about this when we do, when I show you in Excel how Excel tries to do Excel tries to do histograms, and then how you should do histograms, because, like a 37 distance is weird. Like, why would you have a 37 size? That's bizarre. 25 is a nice round number, 50 is a nice round number, 100 is a nice round number, 37 is weird, 42 is weird. Any questions on this? So, but admittedly, this is a little arbitrary, these bin sizes. Right? We decided I was going to have 1, 2, 3, 4, 5, 6, 7, 8. Why 8? I don't know. It's a good number, right? It'd be nice if we had something systematic so we can compare across things. And that leads us to a box plot. I'm actually going to write a box plot over here, but I want to show you one first. Here's a box plot. Sometimes you see them vertically. This one I drew horizontally. It's also hypothetical data because this is not the range of household incomes. Box plots divide data into quartiles. Does anyone know what a quartile is? Yes, what was your name again? Gabe. What do you got, Gabe?
So, the first one, is 27.5 is so it's kind of 25% more. And then,
what does that mean, 25% more?
So, the first quartile, the first quarter, people or households, and then the 35 would be 50% more. So the median, and then the 40 is 75.
Mm-hmm. Exactly.
That'd be a third.
Yep, third quartile, and then here's the fourth. Right. So the top 25% of household incomes are between 40 and 50,000. No, I'm using this in thousands of dollars. And the bottom 25% are between 15 and 27,500. Oh, I should realize I should probably like see it. So this is nice. It has these clean lines. We divide it into four. Sometimes it's called a box and whiskers because it's like a little cat with whiskers. And you also get some idea too of dispersion, of how the data is spread out. But like a histogram, you don't know what's going on within this range. You don't know if everyone, like of that bottom 25%, everyone is 15,000 and there's like one person is 27.5. You don't know if it's the other way. You don't know if it's uniform across. You know what's going on within it. But you at least get some idea of the dispersion. Not just across the whole sample, but within these pre-described ranges. Oh, I need to erase that. Box plot. Divides data into 4 equal parts. Which we call quartiles. Q0, with the 0th quartile, is known as what? Anyone? Beginning? The minimum. In our example, 15,000, right? The smallest income we had in our sample, the smallest number. Q1 is our first quartile. This is also called the 0th quartile, if you want to put that in. Q2 is our second quartile. Also known as what? Just add this 0th quartile. The median. What is the median? The middle number, right? Exactly. So note, 25% of observations are between this one, 25% of observations are between this. This is half the observations. The other half are on the other side. This is our middle number. Q3, what do you think we call Q3? Third quartile. Q4, fourth quartile, also called the maximum. So, 25%, 25%, 25%, 25%. Divides it into 4 numbers. Thus, we only need 5 numbers to make a box plot. The maximum, the minimum, the first and third quartiles, and the median. What's nice too is that these bins are not arbitrary. All box plots operate on this system of 4 quartiles. So like some histograms might have bins of 50, and some histograms might have bins of 5,000. All box plots operate on 4 quartiles. So you lose a little bit of arbitrariness in it. But again, we don't know what goes on inside a quartile. Although we do know some sense of the distribution across quartiles. Imagine this is my data. What can you tell me about the third quartile versus the first quartile? Yeah, the range, the distance between the minimum and the maximum is really small. While this distance, what is it like? Oh, it's huge. So what can you tell me about the observations in the first one and the observations in the third?
They're more similar in the third?
Yeah, they're more similar in the third, right? We know that they all must be densely packed here too, because this has 25% of the observations, and this little sliver also has crammed in 25% of the observations. Again, they might be all on one side, might be all on the other, they might be uniform, I don't know, but they're all very similar. They're all right there. So it gives you a little sense what it's like, yeah. Yeah, that's true too. Again, it could be like a lot of the observations are here, and then there's one right over here. Again, we don't know what's going on within. But we do know in general this is probably pretty dispersed. Well, this is probably pretty much the same. But you can't be sure. Notably, you cannot tell where the average is. Just like in a histogram, you can't technically tell where the average is because you don't know what's going on within each bin or within each quartile. You need the raw data for that. Any questions? This is a side note too. I often see these vertical. So if you ever want to know what it looks like, the vertical line just looks like this. But this is the max. And this is the min. This is not the same one. That would be roughly this one. Right on that side. I sometimes see them this way. If you go to like predicted, which lets you bet on outcomes, like political outcomes, I think sometimes you can see the box plot of prices, and it displays them in that way. All right, no more questions. All right, I'll let you go. Have a great couple of days, everyone. When we reconvene on Thursday, we will then get into how to make these displays in Excel, as well as some other displays like pie charts, bar charts, and scatter plots. I will see you then. Have a great couple of days, everyone.